So this is an example problem. Imagine we have a 3-kilogram box and we want to know how much force is needed to make the box move. And we know that the coefficient of kinetic friction is, let's call it 0.1, and the coefficient of static friction is 0.3. So in order to solve this, let's give ourselves some more space. But we start off by drawing our free body diagram. Right now, we need to see what would happen to make. So this force of gravity pushing down, normal force pushing up, that's going to be equal mass times gravity, which equals 3 kilograms. Okay, and we know the net force in the y is going to equal 0 because it's not accelerating. It's not, boxes are moving up into the air, it's not moving down into the air. So that means the normal force minus the force of gravity minus, because it's pointing down, is going to equal 0. So 0 equals the normal Okay. We need the normal force to find the friction force, because in order to find the friction force, we have to remember the equation that the force of friction is equal to the coefficient, the terrible drawing coefficient, times the normal force. Now we know the normal force. Now, are we going to use the kinetic, or are we going to use the static? We're going to use the static because the question wants to know how much force is needed to make the box move. So that means the force of friction needed to make the box move is going to equal 0.3 times 29.43 newtons, which will give you 8.83 newtons. So there's a force of static friction equal to 8.83 newtons. So in order just to make it move, we have to exert 8.83 newtons. So that means if we exert 8 newtons, it's not going to move. If we exert 9 newtons, it's going to move. So let's make that the next part. So let's go ask another question. If we exert 9 newtons, what is the acceleration of the box? Alright, so first of all, the box is going to move. The reason I know the box is going to move is because 9 newtons is bigger than 8 newtons. So that means it's going to move. Now once it starts moving, we have to jump to static friction. So to jump to static friction, we have to figure out what the force of static friction is. So right now in this situation, we're going to change this and imagine that there's 9 newtons pushing this way, and there's a force of friction pushing that way. Because the box is now moving, our force of friction, we have to take into account the kinetic force of friction, which is going to be still the same formula, the coefficient times the normal force, except now we're going to use the kinetic coefficient, 0.1 times the normal force, which is still the same, 29. So our force of kinetic friction is going to be 2.943 newtons. So on our diagram, we're going to have 2.943 newtons pushing this way. So this is our box. And 9 newtons pushing that way. So what is our total acceleration going to be? Well, our total acceleration is going to be, well, we have to use the net force in the x is going to equal to mass times acceleration in the x. And that's going to equal to our two forces, which is negative 2.943 plus 9. Those are our newtons. Our mass of our box is 5, so 5 times the acceleration of the x is going to equal 0.057. So we divide both sides by 6.057. And we get 0.825 meters per second squared is going to equal our acceleration. So if we exert 9 newtons, our box will accelerate at 0.825 meters per second squared.